Thank you. So what I want to talk about today is sort of a theme that my lab has been working on for the past couple of years, which is sort of around the idea of code stories, and in particular, sort of using the history that accompanies what happens when we develop, in order to sort of support programmers reusing that code or sort of reintegrating and re-engaging with it later. So, assuming my thing will go. Oh, come on. Here we go. Okay. So I suspect that many of you have had an experience like this in trying to look at someone else's code base where you feel like you're sort of walking through the jungle trying to figure out, what everything is and why is this structure here and what on earth is this thing trying to lead to, and wow, there's a comment here, but it doesn't make any sense to me. So you sort of it's overwhelming and it's hard to figure out what exactly is going on. And if not that one, perhaps you've had this one where you are, happily working on something, you're, in a groove, you've got everything going, you've got a perfect plan, and then something happens. It's the weekend, you have to go to a conference, you've got a paper deadline, and you have to stop working on this because you've got to get your paper in or whatever it is. And you come back some number of days later and you're like, what is this code? Where the heck did it even come from? And what on earth was I thinking? So at the root of both of these experiences is code comprehension, which is hard. And it's hard for a lot of reasons. This is an incomplete list. But one of them is that, this is a very nonlinear thing at its core. So it's nice to be able to sit down and read a novel from beginning to end and have information revealed to you when it, should be revealed to you. And you can't really do that with code because it's sort of, when a particular thing happens, it might be touching multiple code files, etc. To complicate matters further, there is also a gap between what the code is supposed to do and what it actually does, between its intent and what is actually implemented. And the combination of both of these things tends to lead to high working memory demands. So you have to keep track of a lot of different things and be able to integrate them in order to make sense of what's going on. And then to complicate things even further, you may get misleading signals from the code itself. You may look at, the name of a variable or something that's called and assume without really fully reading it that this signal means something that is not actually correct. This was summed up. We've been doing some studies actually on AI-supported debugging, which I'm not going to really talk about. But one of our recent study participants sort of summed up this code comprehension difficulty nicely in saying, I think the most important thing is to slow down and really understand what the code is actually doing, not what you think it's doing. So Thomas Latosa and Brad Myers did this wonderful paper a number of years ago that was on sort of software engineering practitioners and the questions that they find hard to answer when they start to engage with a code base that is unfamiliar, whether it's unfamiliar because it's something they didn't write or it's unfamiliar because it was a long time ago and they've forgotten. And so they come out with a whole bunch of conclusions about, what is difficult. And some of the things that jump out are, questions of things like, why was this written this way? Or what exactly was this supposed to do? Or did this ever actually work? And one of the things that was notable from the study was that, questions involving the history or the process are actually particularly difficult to answer. And so one of the things that this led to for us is that, you can really start to think about software development as being a story where, we begin with a problem and, we come up with some idea about how we're going to try to solve that problem. And then, something goes wrong. We meet a dragon And that, creates a new problem. Maybe we turn to Stack Overflow or we ask ChatGPT to do something for us. We eventually find a solution. We integrate that all back in. And, a typical programming session might be a whole series of these events where we, encounter some kind of an obstacle, we do something to try to solve it, and then, we then move on to sort of the next thing. And thinking about code development as a story is actually interesting. And one of the reasons for that is that as humans, we are actually well set up to process information in story form. So there have been a number of studies that have looked at the benefits of sort of presenting information in narrative form, and have found that people are actually more likely to remember information when it's presented this way. And that actually there's some research that suggests we actually have special mechanisms in our brain for sequential memories for, this happened and then this happened and then this happened and here's how I responded. And so that kind of led us to well, okay, we've got sort of this story sequence that makes up the process of programming. Supposing that we try to capture that, what might that look like? And there are really kind of two sides to this, and I'm going to talk a little bit about both sides. So the first, and this is the St. Louis Arch for those of us who maybe don't see it every day. It's a very prominent feature here in St. Louis. So one side that we're going to talk about is, how we actually capture the history, and there's a bunch of, interesting problems that arise there. And then once we have sort of a history that we can work with, how do we actually present it in a way that's useful? And we're going to talk about some different examples of how that might be. So we'll start with the history part. One of the questions that I often get when I start to talk about this is like, well, I mean, isn't that what Git is for? Like, we already have, a history. Like, why don't we just read the Git commit messages and be done with this? There have actually been a lot of studies of Git and what it does and doesn't capture. But it is a very sort of programmer-driven process. And what tends to come in is that you don't want to commit it while it's still broken and not quite right. And so as a result, the commit messages tend to be, the end when this whole story has already come to pass and we've done all the things and we've bested all the dragons and we've now added this new feature and 781 lines of code have been added and 65 have been removed, and then ta-da, it's finally in a good place, let's commit and push it. And alongside that, there's often programmers will take on multiple challenges at the same time. So, it's like, oh, well, while I'm here doing this other thing, hey, I noticed that this part kind of stinks, so I'm going to change that while I'm at it. And as a result, it can be really difficult to sort of match up, the changes that were made to what was actually intended, and also to answer these questions about, what was going on here and importantly, why. And part of this is because the process that programmers go through is actually pretty complicated and full of a lot of context. So, we might take this example where we have some broken authorization, something or other going on, and a programmer goes and searches for information on like my JWT auth thing is not working. And then, makes it to Stack Overflow and finds something from Stack Overflow, but it doesn't work. And then they turn to ChatGPT and they say, hey, why does this fail after I changed this thing? And, they wrestle through some debugging logs and they check some other things. And eventually, they get to some kind of an answer. But along the way, a lot of things have been tried and a lot of information has been considered. And some of that information contains some really important insights about why the particular solution that got embedded into the code was the one that got embedded into the code. And so, behind that whole story is this process that we have, and there's, specific actions that we take as coders that capture pieces of the story. So, our web search that we do might give us some insight into a particular barrier that we've encountered. So, my connection was refused and tell me some things about that. Um, it might give us a particularly influential example. So I do a whole bunch of foraging or I have a whole conversation with an LLM, and eventually I get to this one example that really guides how I tackle the particular program or the particular problem in my program context. Or I might get an explanation that I really needed, that, I have this crazy behavior that I don't understand why it's happening the way it is. And eventually I find, something that will give me insight into what's going on. And right now, all of this information just sort of disappears into the ephemera. We don't have a record of it. But a lot of it is very relevant to these hard to answer questions and, can give us the ability to kind of reason about where things are coming from, how the particular solution took shape, how it was being thought about, etc. And so a couple of years we sort of asked ourselves, well, suppose we try to, actually record the story, like what would that mean? And we're not the only people who have thought about recording history, although most of the work that has been done has really focused on recording just the state of the code. And even there's a huge range going from let's capture every single keystroke that a developer, makes as part of getting a program from beginning to end. And obviously there's a lot of information there. It is impossible to argue that something important might be missed. But at the same time, the size of the data is really, really big, and it's pretty distant from the sort of the level of the programmer's thought process. And so that creates a different problem, which is now how do we turn this into something that's actually useful? On the opposite end of the spectrum, we have no history at all. We just have, here's the current state of the code. So we, started this and scratched our head around it for a while. And eventually what we arrived at is that we wanted to do things in terms of an execution history, that when a programmer runs their program, that is a declaration that it is in a state that is worthy of getting feedback. It is not in the middle of something. I'm not halfway through a thought. I don't have a plan that's, in some partial state towards something. I have something that I'm ready to test. I'm ready to get some feedback on. And so we decided to capture the code history, just the program code history at a level of the execution process, which is its own interesting challenge. It turns out that is not as straightforward as you might hope, but I'm not going to have time to go into that. So alongside this, we have, sort of the code changes, and these are captured at every execution. And then we have sort of, web foraging behavior and LLM conversation, which is, coming in fits and spurts, but it's not a totally complete process yet. And that has been combined into a code histories framework, capture framework that we've developed. And that has two main pieces to it. So the first piece is a VS Code plugin that tries to detect when a program is run. And that is an interesting thing, especially given the sort of diversity of kinds of programs that there are. So it's very straightforward when you're just sort of running something at the command line. It gets more complicated when you're developing something that is designed to run in a browser, for example, or is running in some kind of an external emulator. And then the execution actually has something to do with when a programmer is actually interacting with it, so that you sort of get that testing action that's going on. So the VS Code plugin basically watches for program executions, and it uses a shadow Git repository that records a commit at every point that the code is executed. Alongside this, we have something that sits in the browser and has a bunch of controls on it so that you can sort of set, this is my coding reference window and this is my email, and me distracting myself through whatever mechanism I like to distract myself with, and I'm not interested in having these be part of my my code history. So those sort of automatically capture and then sort of send it through to VS Code. And so ultimately they all get committed into a single kind of shadow Git repository. At the end of the day, that's still a lot of information. So if you think about, your process of developing a piece of code, there's a lot of testing that happens. I try something out, a particular value is too big or too small, and then I tweak it a little bit, or I want to change the way that something is appearing on screen, or I'm, testing something over a bunch of different kinds of cases. And so if I actually tried to sort of look at the full set of testing activities that happen over the course of development, that's still a huge amount of information. And so we've come down on the side of it's really valuable to have that core record because it gives us a lot to sort of pull back on, but actually we need to do some processing of that in order to kind of make it at a level that is more in line with what is going to be useful. So we did this by observing a couple of things. So the first is that often when you are working on something, you'll end up making a lot of very related changes quickly. So I've, trying something with a width and a 4, and I don't like that. I'm going to change it to 5, and then back to 4, and then back to 10, and then I'm actually going to change it to something related to an image size. And at the end of the day, maybe I don't need to see all of these things. Maybe I just need to know that, we started at 4 and then we changed it to, being related to this image size. And so what we've done here is we go through and we have sort of a heuristic process that goes through and looks for code that is being changed in sort of similar parts of the code. So if you're sort of touching a line or a couple of lines over and over and over again, those get grouped together. And then the new groups of code are created when a whole bunch of new things are added. So several lines are added. And often this comes out of, sort of watching what the process is like for a lot of people, where what happens is you go and you have a new goal in mind. I'm going to make something happen. And then you add a bunch of lines to support that. Those lines are invariably wrong. You test it, it doesn't work. You change some things, you test it, it still doesn't work. You change some more things. And eventually you get to the point where it's like, okay, I've accomplished this goal. And so we call those little pockets of short development sub-goals. And you can see those as sort of part of the longer story of where the code is going. And so these eventually get kind of organized into these higher level goals where we have, it's like, well, how are we going to load an image in Python? And then we're, reading stuff on a web page about reading images in Python. And then we've added some code into main, and then we need to search for some additional information. And so we then organize all of those into sort of a higher level sub-goal, which is about accessing image data in Python. Okay, so the end result of this is that we can record a detailed history that includes the code state each time the code was executed, and then these get grouped into sequences of related changes. And then alongside that, we have the foraging behavior that occurs and is intermingled with code editing. So that gives you sort of a flavor. There's obviously lots of details in what has happened there that I can't get into. But the second question becomes, okay, so now we have this fairly comprehensive history along with kind of the context of what's going on. How do we present it, and how does that sort of enter the workflow of a programmer? So how do we tell this story? So we started out inspired, excuse me, in part by these hard to answer questions. Um, Thinking about two different types of stories. So the first one, sort of feels a little bit more like kind of a Git-ish history, in that, we have sort of these sequences of short goals. So this shows you one sub goal. We're trying to figure out how to select a Wordle answer at random from a list of potential words, and it shows us sort of what happened. So we, put some goals into a requirements document, then we went and searched for selecting an object from an array. Then we looked, we edited a particular code file about how to do that, and then, continued on a search. The other thing we did, and this actually, sort of started almost as a joke, was we took that sort of list and tried to turn it into kind of a fairy tale style story that told, that told the story of what happened kind of from beginning to end. Um, and initially we built one of these by hand, and then in the middle of that, ChatGPT started to really take off, and so we started looking at can we use this list of sub goals and have it build a narrative story for us. So I have sort of examples of both of those. And we ended up doing a fair amount of sort of formative testing on this, trying to figure out how to integrate it into programmers' workflow in a way that it became a source of information that they would leverage. Initially, we had this as sort of a separate sort of web document that you could go and look at, and you could open up all of these things to get more details about stuff. And we found that once it was sort of out of the IDE context, that it was sort of, out of sight, out of mind. It was too much of an interruption to go into a totally different context to sort of pull at this history. And so we put a view into the IDE that is kind of the history view. And so this just, zooms in on it, and there's a little bit of a search function, so you can look for things. But all of these little boxes open up to show you more details of things, and then you can click on stuff within them. So in this case, I can look into, okay, well, I did a search on how to select a random object from an array. And as part of that, I went and looked at this introduction to JavaScript arrays and how to shuffle elements in a JavaScript array and how to do prototyping. I can also open the code itself, and I see sort of a diff of what it looked like at the beginning and what it looked like at the end. And so you can see that this was initially declared as a constant and is now a let, and that I've added a whole bunch of things about sort of, choosing a word, and sort of an implementation for that. The other thing that we found was really necessary was that there was sort of a bi-directional way to access these things, that you could go from the code to sort of the history. So where did this come from? What is its story? But also from the history into the code. And so you see here the code into the history. So we have this choose word thing. And at the bottom, I call your attention to this little C history text, which you can click on, and then that will take you to the relevant section of the history that shows where this particular change happened, or this series of changes happened. We can also go from the script into the code. And so if I open up the script here, and I can see, the diff that happened for this jump tiles thing, I can see this either in the code or actually also in the story. And so it'll take me to these alternative representations to see what is happening. And it's important to note that the code here may actually be different. So the code in the history represents what it looked like at that point in time, which may not actually look exactly like what it looks like now. So often, especially with complicated parts of the code, you'll find that they don't just get edited once. This new thing gets added, and then some other things come in, and then somebody has to come back to change this in some new way. And so, particularly sort of high touch parts of the code will have lots of entries in history that touch them. Um, and then we also sort of have this story view, so you can sort of see this as a history that's, a list of items, and also as this story view. Okay, so we did a whole bunch of formative testing trying to sort of get people to, be willing to use this at all, to be able to use it to sort of answer questions and to get into things. And so then we wanted to kind of look at the question of, well, does it actually help? And that leads you into the help how exactly. And so we did sort of a series of small studies where we looked at different aspects of how this information might be useful. And we took both the sort of sub-goal list view and also the textual story view were available to people in this study. And so we looked at tasks that were about testing, modifying, and fixing bugs. We looked at tasks that were about answering hard to answer questions. And we looked at repurposing existing code for a new purpose. And all of these show some promise. I'm going to kind of breeze through them a little bit quickly. But, we had the majority of users we put this into a system that we called DevTails to locate the code responsible for behavior of interest. And that this in particular helped to address, misleading cues and understand the code intent more easily. We also had a lot of them programmers who would sort of look at the code, and the code itself wouldn't be enough to really understand exactly what was going on. And they would sort of deepen their knowledge by revisiting resources that were visited by the original developer. And in particular, this happened in the Wordle code base with a regex expression that the original developer had actually incorrectly excerpted. And so the user who was looking at it went and kind of looked at it and was like, I don't really understand what this is doing. And they dug into the sort of source material that the original developer had looked at and reread it and was like, actually, I think they've done that wrong. And they were able to sort of correct and fix the problem that way. And there were a lot of examples that had that flavor. We also included answering hard to answer questions. And so these were tasks that asked programmers about the rationale, the history, and the provenance of code that was within an image processing app. And we chose an image processing app because it was a little bit obtuse. So what was going on was hard to figure out just looking at the code itself. And so it really required people to kind of dig in a little bit deeper in order to figure out what was going on. What we found was that everybody started with kind of a top-down navigation through the sub-goal history. So instead of delving into the code initially, they would read through the history, try to find parts of the history that were related to what they were doing, and then they would use that as kind of a jumping off point to get into the code. And many of them actually leveraged the story formats to understand the rationale and reasoning about implicit information. And it was seen as really valuable to sort of have this textual story format to be able to sort of understand a little bit more of the thought process. And a lot of our users actually talked about that, going through the text story, they felt like they were able to kind of get into the original developer's mind and kind of see the progression of the code as sort of a problem-solving process that this person went through. And that was a cool thing to see happen. That said, there were, a significant minority who initially very much avoided the story view. They sort of looked at it and they were like, oh, this is a lot of text. I don't really want to read all this text. But of those people, when they were eventually got to a point where the story had something that they needed in it, they would sort of read through that and then they were sold. So they would leverage it pretty heavily after that. So that was interesting to see as well. And then we did a third group that looked at repurposing existing code for a new purpose. And so this is another sort of image processing kind of context where we asked them to take it from one setting and then use it in a new way. And so it requires being able to identify what parts are there to think about what they're doing well enough to sort of see opportunities to shift what is going on in a new way. And what we found was that the majority of them were able to successfully locate and identify the code that was sort of the best code that they could repurpose in this particular code base, and that most of them were able to then, understand what the code was doing well, well enough to sort of be able to answer our questions about it. Most of them favored the sub-goal histories for these tasks, and so we didn't see in this particular set of tasks a lot of use of the sort of the textual story view. So I would say, overall, what we found is that there's evidence that historical information has the potential to be helpful across a variety of code tasks. And there's also evidence that the ways that the information is presented and integrated into the workflow matters. That we have to sort of think about how it intersects with workflow, and that some tasks may need different styles of information than others. And so the notion of having, a core recording framework that has enough detail in it to be useful, and then being able to create kind of custom views for particular kinds of things is a workflow that shows some promise. But this feels very much like we're scratching the surface, and there's more to be explored here. And one of those things is that, as we were writing our own code, what we found was that we started to look into the histories that were being recorded as a way to address the interruption problem. So I'm working on something, I get interrupted, I come back a couple of days later, and I did this myself, right? I started looking at, like what was the last thing that was recorded, and using that as a way to try and get back in my own head of what was going on, and using that to then, get back in track more quickly. And so we decided to look at the use of these histories in the context of supporting interruptions as well. This creates a new technical challenge for us, because what we had been doing was sort of recording the histories as a separate process, and then, offline doing a processing to sort of create the history documents, and then sort of make those available to people. And for it to work in an interruption context, we sort of need it to be capturing things as people go, and then, sort of continually updating. And so we, did some magic to make that happen. And so what you see here is kind of a split view. And it kind of gets at the underlying infrastructure that's going on a little bit. So we have, at the top here are sort of what are equivalent to our sub-goal pieces. So here are the things that were added in response to a particular goal. But then, as we talked about, often in the path from, okay, I have this problem that I'm going after, to, okay, now it's ready, and I've got a chunk that's kind of done, and I'm ready for the next sub goal, has a lot of individual, testing behavior that happens. And so what we chose to do is to sort of present those in this in progress work section at the bottom. And then, once something had gotten to the point where we could say, okay, here's a sub goal, here's what it's about, then it would get migrated to the top. And similarly, just like the view that you saw earlier, this is something that you can sort of open up and delve into. So here's, a diff, and along the side, you can see, here's kind of the search information. There's a little summary of what's gone on, and here are the things that, people interacted with while this was occurring. So we looked around, and there's some really nice work by Chris Parnan and Rob Deline that happened a few years ago that was also on interruption support. And they looked at sort of a tree view, and then sort of this context history where it basically sort of captured, you were messing around in this file, and it shows diffs, and it shows kind of movement of files and so forth, but it basically is just kind of a running list of, here's actions that have happened. And the results of their study suggested that this kind of running list of the things that were happening was more helpful to people. And so we decided to kind of take that as a comparison. But there was this critical difference, which is that, in our history, there is also all of this other stuff about sort of looking at, related resources and so forth. And so what we did was kind of create a version of what they had that also integrates the rest of the history information. And we used that as one case. Um, and so we ran a study where we did kind of a balanced version where people sort of got, up to speed on one of the two interfaces, either our sub-goal-based history or the context history that was inspired by Chris Parnan and Rob DeLine's work. And then they had 45 minutes to do a programming task, and we interrupted them. We interrupted them randomly between minute 11 and minute 16 for a first time, and then again after that with at least 5 minutes apart between the two. And the timing here is sort of based on, some data about how long it takes to kind of get into things and start making forward progress and so forth. And then they did the same thing with the other one, and we can kind of then do a within subjects comparison between them. And so there was some interesting, promise here as well. What we found was that people tended to leverage the sub-goal history more frequently as part of recovery. So about almost 3/4 of post-interruption periods used the sub-goal history versus a little less than half for the content timeline. And although it didn't quite get to significance, the history users were actually a little bit more successful at recovering. So they, sort of got through their interruption and were able to make new progress, sort of break new ground in the tasks that they were working at more frequently. And so they were looking at the sub-goal history, and we had a little bit of an interview afterwards where people sort of talked about things like, the history was more helpful because you can kind of track down what you were Googling, and it was, cleaner and to the point, and it's sort of, writing its own commit message. And so it was, allowing people to kind of get their train of thought back a little bit more easily. We are currently in the midst of running a study that looks at longer interruptions. So this is one there where there's, 1 week about in between sort of one development period and another development period to try and understand whether there's sort of a difference in the kinds of support that are necessary for these sort of shorter term interruptions. I went to get coffee, I went to the bathroom, somebody came into my office versus I went to Florida for a week and now I'm back. And we are also starting to play around with asking questions of history. And so we have this, rich record of everything that was done. And so, using LLM support, starting to ask questions, how did the user approach this? How many times did this change? What were the parts that were most the biggest struggle for the person who was developing this, and being able to really kind of take these higher level process questions into place. And so that's sort of a quick preview of what that looks like. And it has sort of two pieces to it. So it sort of gives you a summary at the top of, so this is an example where it's like, how has key press detection changed over time? And it gives you kind of a summary of, well, it came in here and then it was improved in this way. And then, regular expressions came in, et cetera. And then it also gives you access to the aspects of the history that were relevant to that particular question, with a little bit of context around what was happening in each of those. And we are sort of in formative testing a little bit with this, and honestly just playing with it ourselves, trying to think about, what are the kinds of questions that people, would ask, given that there's now this rich history to play with. So I will conclude by hoping that I've convinced you that there's a lot of really fascinating information that comes out of process. and that, particularly in the context of programming, that process information has a lot of really valuable material in it, and really valuable insight. But also that when you do this, the presentation matters. Obviously, there's a whole design space of different kinds of things that could be made, different kinds of visualizations, different kinds of resources. And we've only just begun to explore, how best to process it and integrate it into a programming workflow. One of the things that we've tossed around and haven't started to play with yet is, thinking about histories as a resource for, both self-assessment and artifact assessment. Where should I try to be better based on what it is that I'm doing? And, given the process that's gone into this, can that tell us something about where it might have shortcomings? Did somebody not, spend a huge amount of time on the, authentication, for example? And so there might be a security risk that, should be considered.